Hey everyone, welcome to Math 104 Intermediate Algebra. This is our first lesson, and we're going to be covering sections R5 and 1.1. First thing we're going to talk about is set notation. A lot of the equations we're going to be solving have more than one solution. Some of them may have two solutions, some of them may have infinite numbers of solutions. So we're going to need some notation to describe these solution sets. So first thing is set notation. So sets are enclosed in these things called curly braces. They take a little bit of practice to draw. If you just draw kind of a squiggly line, I'll know what you mean. So each number in a set is called an element. So 1's an element, 3 is an element, and so on. 6 is not an element of this set because you don't see it listed there. Now this is what's known as a finite set. It has a finite number of elements, in this case 4 of them. But some sets have an infinite number of elements. So in those, we write the pattern. So here we've got odd numbers, 1, 3, 5, 7, positive odd numbers. And then we put a comma, and then 3 dots. Those are called ellipses. That means the pattern continues forever. So this would be all positive odd numbers. 1, 3, 5, 7, 9, 11, 13, and so on. So there's an example of an infinite set. Now an empty set, it's a set with no elements, because some equations have no solution. So we're going to indicate that with a circle with a line through it, the empty set. Now I've got some number systems. Think about, here's a list of numbers, -3 through 3, and we got the ellipses, meaning they go on forever. All these numbers are called the integers. That's all positive and negative whole numbers. Now subsets of that, we got the natural numbers, otherwise known as the counting numbers. So that's 1, 2, 3, and so on. All positive whole numbers. And then we have the actual whole numbers, which are 0 and on up. So the only difference between the natural numbers and the whole numbers is the whole numbers include 0. Natural numbers do not. And the integers include 0 and all the negatives. So those are 3 number systems that you should be familiar with. And there's also the real numbers, which includes everything, all the decimals, irrational numbers like square root of 2 or pi or stuff like that. And the last vocabulary item here is set builder notation. So this is notation we use to create sets of numbers. So it has a certain form to it. We start off with a curly brace. Sets always start with a curly brace. And then we tell what variable we're talking about. So the variable goes here. So for example, it might be the variable x. And then comes a vertical line. And this is read as such that. So it means all values of the variable, such that, and then a list of requirements. Now if there's no requirements, we're just talking about all real numbers. So that'd be everything. But we want to narrow it down a little bit. So we could put something like this first example. X such that x is a natural number. So we've already narrowed it down from all the real numbers to just the natural numbers. Now we're talking about 1, 2, 3, and so on. And then this other requirement here, less than 8. So it has to be a natural number less than 8. So let's figure out what that's going to be. So when we write the set, I always start with a curly brace. We got the natural numbers that start at 1. We're going to do 1, 2, 3, 4, 5, 6, 7. 7 is still less than 8. But if I put an 8 there, 8's not less than 8. So 8's not in the set. If we wanted to include 8, we would say x is a natural number less than or equal to 8. So there's our set, 1 through 7. All right, that brings us to your turn number 1. And it's critical for the learning process that you do the your turns. There are a bunch of advantages to doing the your turns. First of all, the homework problems and the exam problems are going to be similar to the problems we see in this packet, and that includes the your turns. So this will be great practice for the exams and for homework assignments. Next, if you do them here in class or while you're watching the video, then you can ask questions right away. That's the best time to ask questions because if you don't ask questions right away, you can start some misunderstandings that lead to all sorts of mistakes later on. So best to address any misunderstandings or errors now. And it's a lot easier to get questions answered early versus like maybe the night before an assignment. Who knows if you'll be able to find help. So start early and start with your turn number 1. Now I don't pause when we get to the your turns. So if you're watching the video, just pause the video, work on the your turn. When you're done, start the video back up. All right, in this case we have x such that x is a whole number less than 5. Now the whole numbers, those include 0. So we're going to have to start here with 0. 1, 2, 3, 4. And we want less than 5, so that does not include 5. So the set is 0, 1, 2, 3, and 4. All right, next up, we have list the elements of the set. X is a whole number greater than 5. Now, up till now, we've been working with finite sets. So with the natural numbers, we have 1's the smallest natural number, so we can't go any lower than that. And we're given it's less than 8. So we have both a lower limit and an upper limit. So that gives us a finite set. We have a different situation here. Here we want x is a whole number greater than 5. So anything 5 or less is not in the set. So we're going to start with the number 6. Now it's whole numbers, so it's go in order sequentially. And then once we establish the pattern, use at least 3 numbers to establish the pattern. It's all numbers greater than, so this is going to go on forever. This is an infinite set. So we need those ellipses to indicate that it goes on forever. Your turn, number 2. X is a natural number greater than 2. That means we're going to start with 3. So 3, 4, 5, and ellipses. All right, now we've got one where we're not going to go sequentially. We've got x such that x is an integer multiple of 3. Now, if you don't know what a multiple is, I recommend looking at the preliminaries video. Cover it there. All right, so we're talking about integers. So that's going to include positive and negative numbers and multiples of 3. So that's 3 multiplied by any number. 3 times 0 is 0, so we know 0 is going to be in there. Negative 1, that'll give us negative 3. If we multiply by 1, we get 3. If we multiply by 2, we get 6. Multiply by 3, we get 9. So we're basically counting by 3s. We have to go in all directions. So it's going to look like that. All right, so we're counting by 3. Starting at 0, we count by 3s, both positive and negative directions. So 3, 6, and so on. Negative 3, negative 6, and so on. Goes infinitely in both directions, so we need ellipses on both ends. Your turn, number 3. List the elements in the set x such that x is an even natural number. All right, even natural numbers. So the natural numbers, those start with 1. Remember, the whole numbers start with 0, but the natural numbers start with 1. Now we want the even numbers, so the smallest even number greater than 1 is 2. We want just evens, so we're going to count by 2s. Natural numbers go infinitely to the right, so we'll need those ellipses to indicate that the pattern continues forever to the right. All right, now we are going to write out the even elements of the set 1, 3, 5, 7, 9. All right, there are no even numbers in there. So the answer to that is the empty set. A set with no elements in it. All right, now we're going to do the reverse. Using set builder notation, we're going to write a description of the set 3, 6, 9, 12, 15. right, so we've got only positive numbers, so we're not going to use the integers. We're going to either use the whole numbers or the natural numbers. Now, there's two different ways that I can think of off the top of my head we could write this. We could say something like x such that I'm going to write it a little concisely as a natural multiple of 3. So a natural number that is a multiple of 3. And that gives us 3, 6, 9, 12, and 15. Another way you could write it, we could use the whole numbers. We could say, oh, hang on. So a multiple of 3, but we have, right out this set here, we have an upper limit though. So that gets us started, natural multiple of 3. We just need one more requirement here. And then we're going to say x is less than or equal to 15. And so you're going to write little inequalities in there. You can write it in words, you can write it as an inequality. That's fine. But we could, if we wanted to add one more requirement to this, we could say something like x such that x is a whole number multiple of 3. And then x is greater than or equal to 15. Then we could say x is greater than 0. And that would exclude 0. A little more complicated that way, a little more convoluted. So this is definitely a better way to do it. All right, your turn number 4. Think of 3 different ways using set builder notation to write a description of the set 1, 3, 5, and 7. So go ahead and pause the video, come up with 3 different ways of doing that. Think of how you can word the requirements a little bit differently each time. All right, so there's one way of writing it. You got the natural numbers. So this one, it is 1, 3, 5, 7. Okay, so we've got all odd numbers, they're all natural numbers, 0 is not in the set, and x is less than or 8. So that is a complete description of that set. We could write this a little bit differently here, just everything else being the same. So same here, same here. The only difference would be x is less than or equal to 7. All right, and close it off. So a little different version of it there. Here's another way we can write it. X is an odd whole number. Since we're just talking about the odd numbers, 0 is automatically excluded. So the odd whole numbers and the odd natural numbers are exactly the same thing. So here's another way of writing a different version of that first one. X is less than 8 and odd whole numbers. All right, next topic is square roots. Square roots are indicated by the radical symbol. All right, there's a radical. All right, so some number, when multiplied by itself, equals the number underneath the radical symbol. So if we did the square root of 9, we need some number multiplied by itself to equal 9, that's 3. So the square root of 9 is 3. Now there's 3 different situations we need to be aware of. All right, this first one, this is called the principal square root. If you're solving equations, you may have seen this in algebra class before, and this is really a common point of confusion. If we have something like x squared equals 49, and we want to solve this by taking the square root of both sides, well, in this case, we get two answers, plus or minus 7. However, when we're working with just this symbol, just a radical with a number underneath, we're talking about this symbol means the principal square root, which is only the positive square root. So the answer to this is just positive 7. It's not negative 7. That's just by definition. Now in this one, we're trying to take the square root of a negative number. There's no way we can take two negative numbers and multiply them together and get a negative number. So this one is not a real number. Now we do have ways of handling that, and we'll address that in chapter 7. Now we have this one. So in this case, we saw this was the principal square root, gives us only the positive version. If we want a negative number out of it, we'll just stick a negative on the outside of it. And that gives us the negative 7. All right, square root of 49 is 7, still got that negative on there. And that brings us to your turn, number 5. All right, principal square root, that's positive only. Negative of what we found there, so we got negative 8. And this one, not a real number. Now if we want to take the square root of fraction, we'll apply that square root to both the numerator and the denominator. So square root of 9, oops, it's 36. Square root of 9/36. The square root of 9 on top, square root of 36 on the bottom. And that gives us 3 on top. Principal square root is positive only. Square root of 36 is 6 on the bottom. Reduce that to 1/2. Now notice that's the exact same answers we get if we reduce this fraction first. 9 over 36 is 1/4. 1/2. Nice thing about math is as long as you follow the rules, you can do things in any order. You get the same answer. Your turn, number 6. So we'll take the square root of top and bottom separately. Square root of 121 is 11, and the square root of 4 is 2. So 11/2 for that one. All right, now we're going to practice order of operations. Just remember, parentheses first, then exponents, then multiplication and division on the same level, left to right, and then addition and subtraction, always leave those for the last, working again left to right. All right, first example. So we're going to start off with grouping symbols. We've got some parentheses here. Now within this grouping symbol, we do order of operations. So just looking at this part, we've got subtraction and division. We're going to do division first. That gives us 12 minus 9 there. And then here, 8 minus 10 is negative 2. So we have negative 2 to the third power. All right, now we can complete this parenthesis here. 9 divided by 12 minus 9 is 3. Minus 3 times negative 2 to the third power. All right, exponents are next. Negative 2 to the third is negative 8. So that gives us 9 divided by 3 minus 3 times negative 8. Put those negative numbers in parentheses. All right, now we're down to division, subtraction, multiplication. So we're going to do multiplication and division working left to right. Starting here on the left-hand side, 9 divided by 3 is 3. So 3 minus 3 times negative 8. All right, now multiplication. Remember to leave these symbols exactly as they are. 3 minus, leave that, and now we'll do the multiplication. 3 times negative 8 is negative 24. Make sure to put that negative number in parentheses. All right, subtracting a negative is adding, so that's 3 plus 24, and we get 27. All right, your turn, number 7. All right, so we are going to start off with parentheses. I believe that's supposed to be 5. There we go, 5 squared. Okay, so we're going to start inside these parentheses, doing order of operations. We'll start with the exponent, so 30 minus 25. And here we got 18 minus 21, that is negative 3. So that's 3 times negative 3 to the third power. All right, next up, finish off these parentheses. 15 divided by 5 plus 3 times negative 3 to the third. Exponents are next. Negative 3 to the third is negative 27. All right, now we got 15 divided by 5. Multiplication, division left to right, so I'm going to start here. 3 plus 3 times negative 27. All right, now we got 3 plus negative 81. Add these together. This is the same as 3 minus 81. That gives us negative 78. All right, now we're going to look at doing order of operations with some big fractions. This will be good practice for later, so we're going to be working with large fractions all throughout this course, especially the later chapters. Chapters 6 and 7, especially 6, big fractions of 6. Okay, so for this first one, keep in mind that the division bar is a grouping symbol. So you can consider these to have parentheses around them. So we're going to work on the numerator and denominator separately, applying order of operations to the numerator and the denominator separately. So first up, we got a exponent here. So it's 33 minus 2 times 9, positive 9. And down here, we're going to do this multiplication first. That's 2 minus negative 3. All right, now we've got a multiplication here, so we'll do that next. So it gives us 33 minus 18 over 2, and subtracting negative is adding, so 2 plus 3. All right, subtracting these, that gives us 15 on top and 5 on the bottom. We add those together, and the final answer is 3. Now, make sure that before you do this final division, you're down to a single number on top and a single number on the bottom. Only then should you divide to get the final answer. Your turn, number 8. Right up top, we're going to do order of operations. We've got multiplication here and here, so we're going to do the left one. So that's 16 minus 3 times negative 4. Over, and we got it. Parentheses here, we'll do this first. 25 minus 2. We got 23 minus negative 4 squared. All right, now we can do this multiplication. So now we got 16 minus negative 12 on top. Make sure to keep that negative sign, and then this becomes a negative number, so put it in parentheses. Now down here we got 23 minus negative 4 squared is 16. All right, this is addition, so 16 plus 12 is 28. You got a single number on the top. 23 minus 16 is 7. So single number on top, single number on the bottom. Now we can divide to get 4. So some more practice in order of operations we will see here when we evaluate expressions for given value variables. So it's basically the same as what we're doing, except we're given an expression and we need to plug in the values first. So we have here 3b minus b over b minus 2c. All right, so first thing we need to do is locate the values and plug them in. So d is negative 4, so we got 3 times negative 4, and I recommend if you have negative values, make sure you put them in parentheses. 3d minus, and b is 3. So minus 3 on top, and on the bottom we've got b is 3, minus 2, and c is negative 1. So 3 minus 2 times negative 1 on the bottom. Now, order of operations, separately to the top and the bottom. Top, we got a multiplication there, so that's negative 12 minus 3. And here we got a multiplication here, so we got 3 minus negative 2. Now we can evaluate the top. Negative 2 minus 3 is negative 15. And on the bottom, this is 3 plus 2, so that is 5. Divide them out, and we get negative 3. Your turn, number 9. Now we're going to plug in the values. So negative 3 times negative 4 out front, divided by a times b, so that's 2 times 3. That's 4 times negative 1. And on the bottom, we got 2 times 3 plus negative 1. All right, there's our expression with all the values plugged in. Now we're going to start inside the parentheses. So do top and bottom separately. Now we're separated. We got multiplication separated by subtraction on top, addition on the bottom. We can simplify things a little bit, speed things up a little bit by doing 2 times 3 is 6. And then go ahead and do this one as well. Minus negative 4. Since they're separated by addition or subtraction, the two operations will not affect each other. So a little time saver there. We got 2 times 3 is 6 here, and minus 1 on the bottom. All right, now we're going to finish off inside the parentheses. So that gives us negative 3 times negative 4 divided by 6 minus negative 4 is 10. 6 minus 1 is 5. Keep those parentheses. All right, now we are going to finish off inside the parentheses. So that gives us negative 3 times negative 4 divided by 2. All right, now we're down to multiplication and division. We're going to work left to right. So negative 3 times negative 4 is positive 12. So that's 12 divided by 2, divide it out, and we get 6. All right, next up, simplifying expressions. This is something we'll be doing all course, so this is a really important skill. And we're going to work with expressions with nested parentheses. Nested parentheses are parentheses within parentheses. So something like this. We got the outer parentheses. We're going to write those as brackets. And that's generally how it's done. If you have multiple sets of parentheses, it's very helpful in being able to tell what's what by making them a little different symbol. So we go regular parentheses and then brackets. So when we're working on these, we want to work on the innermost parentheses first and simplify here if possible. So everything else, just write it down exactly as it is. Get used to copying down what you're not working on. It'll help keep the large problems straight. All right, now we're going to distribute into these parentheses. So negative 2 into here. Negative 2 times 5 is negative 10, so that's minus 10x. And negative 2 times negative 3 is positive 6. And now we've gotten rid of the inner parentheses. So that's helpful. We're down to one set of parentheses. Now at this point, we could distribute the negative 4 into the parentheses, but that's going to be more work. Why not simplify first? Because then we'll only have to multiply by 2 things instead of 3. So 3x minus 10x is negative 7x plus 6. And now when we distribute, we'll only have 2 terms to multiply by. So a little bit of a saver there in work. Oops. All right, we're distributing negative 4 into the parentheses. Negative 4 times negative 7 is positive 28, so plus 28x. And then negative 4 times positive 6 is negative 24. Now we'll combine like terms. 2 and negative 24, so we got 28x minus 22. Your turn, number 10. So we're going to start with these inner parentheses and distribute the negative 5 in there. Everything else, just write it down exactly as it is. Sometimes I'll see people taking the sloppy route. Well, they'll only write down 10x or negative 10x plus 15 here, and then they'll continue on without writing the other stuff in. I find that that leads to lots of mistakes. All right, so there's our next step. These things come down exactly as written. Nothing changes there. The only thing that changes is this part. All right, now we're going to combine like terms inside the parentheses. 4x minus 10x is negative 6x. So we have negative 6x plus 15 inside the parentheses, plus 18 on the end. All right, now we can distribute it. Negative 18x plus 45 plus 18. Remember, do not distribute end of the 18, only the stuff inside the parentheses. Now combining these constants on the end, we got negative 18x plus 63. All right, next up, this is going to be one of the most important skills in the entire course, dealing with fractions. And this is equations with lots of fractions in them. So 3x over 4 minus 1/6 equals 2x over 3 plus 2. All right, so what we're going to do is get rid of all the fractions at once. And we're going to do that by multiplying by the least common multiple of the denominators. So here we have 3 fractions, 3 denominators, 4, 6, and 3. And if you haven't seen the preliminaries lesson, I'll show you how to find the multiples. The least common multiple of some numbers. So if you don't know how to do that, make sure you watch that. Okay, least common multiple of 4, 6, and 3 is 12. So that means we're going to multiply this entire equation by 12. Now when we do that, that means we multiply every term by 12. This term, this term, this term, and this term. So 4 multiplications to do. All right, so let's start by making it as simple as possible. Take this number, divide by the denominator, and you should get, if you've done it right, if you found the LCM correctly, you'll get a whole number every time. So 12 divided by 4 is 3. So that means we get 3 times the numerator, 3 times 3x. Now here we got 12 divided by 6 is 2, times 1 is 2. All right, here, 12 divided by 3 is 4, and multiply that by the numerator. And you can do this all in one step if you like. You don't have to write it all up like this. Sometimes I show a little bit more just for demonstration purposes. Now here, this denominator is just 1, so we don't have to worry about that. So 12 times 2 is 24. All right, so there's our new equation, and we're going to simplify here. So 3 times 3x, that gives us 9x minus 2 equals 8x plus 24. So now we've taken this nasty equation with all these fractions in it and converted it into a regular old linear equation. So much easier to solve this than this. So I recommend practice this technique until you can eliminate fractions. It'll make your life much, much easier. Now we're going to solve for x. So I'm going to subtract 8x from each side and add 2 to each side. We get x equals 26. Remember, every time you get an answer like this, I'm not going to take the time now, but take this, plug it back in here, and make sure it makes this true. It's especially important with these equations with fractions in it. It's very easy to make mistakes, so always check your work. Your turn, number 11. All right, make sure when you do this, put parentheses around the entire equation to indicate you are multiplying by the whole equation. The least common multiple of 6, 2, and 3 is 6. So we're going to multiply this equation by 6. All right, we've got 4 terms, so we're going to multiply 4 times. 6 divided by 6 is 1, so those cancel, leaving just the numerator, 5x. 6 divided by 2 is 3, times the numerator is 3x. Equals 6 divided by 3 is 2, times 10 is 20. Minus 6 times negative 2x is negative 12x. All right, so there's our equation with all the fractions gone. Now we can combine like terms on the left. 5x plus 3x is 8x. It's 20 minus 12x. And we'll add 12x to both sides. Gives us 20x equals 20. Divided by 20. And x equals 1. So we've been getting whole numbers as answers, but we're we're going to get a lot of fractions as answers too. So you should get good at working with fractions, and finally when you get that fractional answer, make sure you can use your calculator, plug it into the original equation, and check your work. All right, so we got this equation here, 4 minus x over 3 plus x minus 3 over 6 equals 7/12. So one thing that's different about this equation is we've got binomials on top. So we're going to have to be careful when working with those. Let's see, least common multiple of 3, 6, and 12 is 12. So we're going to multiply this entire equation by 12. All right, let's see what happens now with these binomials. So we're going to take 12, divide by the denominator, divide by 3, and we get 4. So that means we have to multiply 4 by this entire numerator. So make sure to put that in parentheses, 4 times 4 minus x. All right, now we'll do this term, plus 12 divided by 6 is 2. So we're going to multiply this numerator by 2. So 2 times x minus 3. Make sure you put that binomial in parentheses. We're going to need to distribute it. And then here we got 12 divided by 12. Those cancel, leaving just the 7 on top. All right, now we can distribute. 16 minus 4x plus 2x minus 6 equals 7. Combine like terms. 16 minus 6, that's 10. Negative 4x plus 2x, that's negative 2x. So 10 minus 2x equals 7. Right now, I'm going to solve for this, so I am going to subtract 7 from both sides and add 2x to both sides. That gives us 3 equals 2x. Divide by 2 on both sides, and we get x equals 3 halves. Your turn, number 12. All right, least common multiple of the denominators, 12, 4, and 6, that is 12. So we're going to multiply the entire equation by 12. Now here, the 12's cancel, leaving just 2 minus x. Here we got 12 divided by 4 is 3, so we'll multiply the numerator by 3. 3 times x plus 4 equals 12 divided by 6 is 2, times 5 is 10. All right, now I'll distribute here. Combine like terms. 3x minus x is 2x. 2 plus 12 is 14. So yeah, 2x plus 14 equals 10. Subtract 14 from both sides. X equals negative 2. All right, last thing we're going to do is we're going to look at 3 types of linear equations. And the usual linear equation we looked at, that's called a conditional. There's one condition that gives us a true statement, the right answer. So a conditional equation has, for a linear equation, it has one solution. Now we've also got identities. Identities is a special situation where it doesn't matter what number we plug in, it's going to make the equation true. So all real numbers are a solution to those types of equations. And then we have contradictions. And that's an equation where it doesn't matter which number we pick, we're never going to make it true. There's no solution to those equations. So I'm going to show you an example of each of these. So first one, we got 5 times x plus 2 minus 2 times x plus 1 equals 3x plus 1. All right, so we're going to simplify here on the left. Start by distributing 5x plus 10 minus 2x minus 2 equals 3x plus 1. Now we can combine like terms. 5x minus 2x is 3x. 10 minus 2 is 8, or positive 8. So we got 3x plus 1. And now, notice that we have the same number of x's on each side. Well, let's get rid of those and see what happens. Subtract 3x from both sides. That gives us 8 equals 1. But 8 does not equal 1. So this is a false statement. So if you ever are solving an equation like this, and you get rid of all the x's, so there aren't any left, and you get different numbers on each side so that the equation is not true, this is a contradiction. A contradiction means there is no solution. It doesn't matter what number we pick to plug in for x, this will never be a true statement. All right, next up, we've got a bunch of 3's in the denominator. We can get rid of those by multiplying by 3. So that gives us x plus 1 plus 2x equals 3x plus 1. All right, now we'll combine like terms. X and 2x, that's 3x plus 1 equals 3x plus 1. Oh, that's interesting. All right, let's get rid of the 3 x's, just like we did last time. Subtract 3x from each side. That gives us 0 x's on each side, and we're left with 1 equals 1, which is true. And this is called an identity. Identity means it's always true. It doesn't matter what value we plug in for x. Could be -5, could be 0, could be 1,000,000. It's always going to be true. All right, last up, we've got 5 times 3x plus 1 equals x plus 5. All right, we're going to simplify on the left, distribute. 15x plus 5 equals x plus 5. Subtract x from each side, we got 14x plus 5 equals 5. Subtract 5 from each side, we get 14x equals 0. Divide both sides by 14, and we get x equals 0. So for this one, we have one solution. We have one solution, that is a conditional. All right, your turn number 13. I'd like you to solve all 3 of those and figure out which one's the identity, which one's the contradiction, and which one is the conditional. Part A, we're going to distribute in both of these. 3x plus 12 plus 4x minus 8 equals 7x plus 4. All right, now we can combine like terms. We get 7x plus 4 equals 7x plus 4. Same thing on both sides. Get rid of the x's. And notice now we've eliminated all the x's, so our answer just has numbers in it. 4 equals 4 is true, so this is an identity. And when you get one of these weird looking answers where the number equals a number, if the same number on each side, that's the identity. If we get a different number on each side, that's the contradiction. All right, so you need to learn how to recognize what the different solutions represent. All right, next up, part B. So we'll start with distribution. -3 in here, we get -3x plus 3 plus 8x plus 12 equals 5x plus 2. Now we'll combine like terms. -3x plus 8x is 5x. Combine, 15. We got 3 plus 12 is 15. And over here we got 5x plus 2. Now we'll get rid of the 5x on each side. And that gives us 15 equals 2. Not true. Since we're left with a number equals a number, but the numbers are not the same, that is a contradiction. Part C. In this case, we got a negative on the outside of parentheses, so we're going to distribute the -1 in here. So -1 times 4 is -4, -4x. -1 times -3 is +3. All right, now I'm going to add 4x to both sides. And since I get the x's to the right, I'm going to add 2 to both sides to get the numbers to the left. So 5 equals 5x divided by 5 on both sides, and x equals 1. All right, we got a single number as the sole answer to this equation. So that is a conditional. It's true on the condition that x equals 1. And that's it for today. I hope you all have a great day.